you can say oxidation of that moiety and the adduction of the same moiety is taking place. Hello everyone, welcome back to PLUTUS STEM. So today we are going to discuss another RAM reaction, that is Cannizzaro reaction. In the previous video we have discussed regarding the Riemann-Tiemann reaction. So this is another reaction of organic chemistry that is very important, and the various questions are being asked in your JEE NEET exam and board exam. So this Cannizzaro reaction over here, the aldehyde or ketone when reacted with concentrated base, so we get alcohol plus salt of acid. So this is the general reaction, how this reaction is going to proceed. So before going into the depth of this reaction, we will discuss some basic points which are necessary for this reaction to be proceeded. The first point of this reaction is that aldehyde or ketone taking part in the reaction, aldehyde or ketone taking part in the reaction must have no alpha hydrogen. Or you can say the aldehyde and ketone which are taking part must have no alpha hydrogen. There need to be a necessary condition. This is a necessary condition. Either aldehyde or ketone which are taking part in this reaction, they don't have any alpha hydrogen. So if you compare this Cannizzaro reaction with the Aldol reaction, in the Aldol reaction the necessary condition is alpha hydrogen. In the Aldol reaction the necessary condition is presence of alpha hydrogen, and over here the Cannizzaro, the basic difference between both of these is that in the Aldol we are having alpha hydrogen presence is required, but here the no alpha hydrogen presence is being required. So if you see a formaldehyde, this is our formaldehyde SCHO. This compound doesn't have any alpha hydrogen. Another example will be like C6H5 C double bond OH. So Benzaldehyde also doesn't have any alpha hydrogen. So these two are very important component of this you can say Cannizzaro reaction. Some other possibilities are like this. Trichloroethanol, or we can also have trimethyl ethanol. So any group which doesn't have any alpha hydrogen, so they can act as the Cannizzaro reaction starting material. So if we are having a reagent like this, so it also doesn't have any alpha hydrogen. So generally we only proceed, most of the reaction will proceed by the formaldehyde and the benzaldehyde. So, and the first point was our no alpha hydrogen, and the second point of this reaction is going to be that it must have concentrated KOH or NaOH. Concentrated KOH and NaOH with heat. Heat is also a necessary condition. And the third point over here is going to be the conversion which is going to take place two moiety are required. Two moieties are required and that are going to convert into simultaneously one moiety will be oxidized, or you can say oxidation, another moiety will be reduced, you can say reduction. The simultaneously oxidation and reduction of the two moiety of any aldehyde or ketone takes place. We are going to explain this when we will be discussing the mechanism, what is the meaning of this, and when within a reaction this you can say oxidation of that moiety and the reduction of the same moiety is taking place. So such type of reaction are known as disproportionation reaction. Oxidation means acid and reduction means alcohol. So such reaction are termed as disproportionation reaction. So if you see over here a basic reaction, this is our hydrogen. So I have told you two moieties are being used. So two HCHO are being used, reacting with NaOH, concentrated and heat. So I have told you one moiety is going to be oxidized and one moiety is going to be reduced, plus HC double bond OOH. So if you oxidize it, one oxygen is being added, COOH, and if you reduce it, it became the alcohol. Alcohol plus acid. How this reaction is going to proceed? So if we see about the pH, another example, Benzaldehyde, the same reagent, NaOH concentrated plus heat, so we will get plus benzoic acid and plus this alcohol moiety and benzoic acid plus alcohol from the aldehyde. Clear? So if we see the mechanism of this reaction, then we are going to see over here that this HC double bond O is being reacting with another moiety, HC double bond O. Over here we are having NaOH. So what is going to happen over here? This OH negative will come over here at 1. It goes upside and we will get HCO negative HOH like this. And because the basic medium is there, concentrated NaOH is there, so in the reaction side we are having excess of OH. So excess of OH means, so if we want to do it like this bond comes over here and this leaves out. So because already we are having excess of OH in the reactant side, so this reaction needs to be proceeded in the forward direction, because if we do it, we are going to come back to the original state or the reactant side only. To push the reaction on the basis of Leach-Atiyah principle, some other thing has to be done. and that will be nothing but this coming back over here, and this hydrogen will attack, take this negative charge hydride ion and will attack at this aldehyde. So if attack in the simple way, if you see over here, this attack comes over here, so it became HCO negative hydrogen, and this hydrogen attachment come over here, so it became SCOOH, and this part it convert into HOH C double bond O. So two moieties we are having over here, this one and this one. Is there any doubt? Firstly, we react this base with the one moiety, this part, we get this, and after this O come back and it attract another molecule of this aldehyde, and we are getting another this moiety. So one acid and one alcohol type moiety we are having. So if you see over here, O negative plus C double bond O H OH. So what will happen now? Some acid base reaction is going to take place, and it became CH3OH alcohol, and it became the salt of an acid, O negative. So this is the whole reaction throughout the process, alcohol and salt of acid. The salt of acid. The same way we can proceed with the any molecule. So one important task which I am going to show you over here is, if we are having two different moieties, this one plus this one, when reacting with NaOH. So now if you see, this is a electron rich species, or you can see nucleophile. It is going to attack at that moiety which is more electron deficient. So at this time, due to the conjugation, it is not needing that much of electron as compared to this one. So that's why it is going to attack over here first, and we will get HCO negative OH, and again this comes back, and this hydrogen attack at this now, because now we are not having any other possibilities. So it will give us a moiety which will be like PH CO negative hydrogen and hydrogen. After this, the acid base reaction, and we get CS3 hydrogen C double bond O plus PH C OH H. So this is like the aldehyde, alcohol. This is going to be the acid, and I'm really sorry, this come back goes up, H attacks over here, so it became the alcohol like this. So this became the alcohol. So this is acid and alcohol. So that easy trick, sometimes just now I also get confused. So it is the good thing we are going to get confused, because it gave us some trick, because it helps that you may also get confused and you can make this interchange to understand this concept. I have a small trick also for this. So this benzaldehyde is a bigger group, and this is a smaller group, less hindered, it is more hindered. And we know acid is a bigger group and alcohol is a smaller group. So more hindered group is going to convert into alcohol, and less hindered group is going to convert into the acid. This is a trick when we are having two different moieties in this Cannizzaro reaction with the strong acid. Generally, this is concentrated acid in presence of heat. For Aldol reaction, we are having dilute acid. So this was for this Cannizzaro reaction. The basic thing, the basic point I have told you, the lack of alpha hydrogen and concentrated acid with aldehyde generally gives us give us alcohol and acid, and this reaction is also being termed as disproportionation reaction. Thank you.